Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Ella and I'm delighted to be joined by Dave Stork, who will be talking to you today about controlling your enterprise mail flow. Remember to join the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC21. Check out the Resource Centre. The Resource Centre is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Join us on November 17th for how Microsoft Visio fits in Microsoft 365 and Power BI with David Parker. We'd also like to thank our webinar sponsors, Docs42 and Pointfire.
Hey you! In the session you will see all about the great options of the Microsoft technologies. But what about generating documents in the Microsoft ecosystem? Like quotes, reports, emails, PowerPoints, and others. The challenges usually are many different data sources, an intuitive design in Microsoft Office, and of course generating the documents where the user needs them. In SharePoint, the Power Platform, Teams, or Dynamics. Docs42 can do all of it. Try now yourself.
Hi, I'm Martin from Pointfire. This year I was hoping to entice you with a booth, games, prizes, giveaways. Instead, we have this short video to show you how we make the multilingual page publishing feature even better. It's so easy, the demo only takes a few seconds.
With SharePoint's new feature, your staff still has to translate each page manually. By adding the Pointfire translator, the pages get translated automatically for your approval. Go to try.pointfire.com for a free trial or contact us for a demo.
Remember to sign up to receive your 30% discount code for our brand new conference, the European Power Platform Conference, taking place in Berlin next April. This discount will allow you to save €300 on your ticket. At the end of the webinar, we will have a question and answer session. Type any question you may have into the question window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and you will be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Dave. Good morning, Dave.
Hi, good morning. Just share my screen here.
Yeah, looks good. I can see it.
Yeah, okay, great. And let's start with controlling your enterprise mail flow. Well, good morning or good evening, good day, everybody, and welcome to this webinar. And the topic of today of this session is controlling your enterprise mail flow. The agenda of this webinar will contain a short introduction of myself, some basic concepts of just general terms, but also SMTP basics. And the main thing are the SPF, DKIM, and DMARC protocols. And some common challenges that I've seen within the organization that didn't have implemented this or are trying to implement those protocols or after implementing those protocols. Also, I'm going to mention some useful tools in when implementing or preparing to implement or testing some things, and also a little bit about the mail header analysis. And at the end, I hope that there will be some time for some Q&A. So without further ado, who am I? Well, I'm Dave Stork. I work about 20 years in IT and currently as a cloud architect at New Nomads. I'm also a Microsoft MVP in the Office Apps and Services section or category. So this is basically a honorary award for doing talks like this and publishing a book, for instance, which I've done a few years back with a fellow MVP Damien Skulls about Exchange Server 2016 and PowerShell, and we still have a lot of books there related on different topics, which I reviewed technically. Other activities contain me being a certified trainer for Microsoft training, so you might have met me there. And for other things, you might have read some of my blogs, books, or other talks like this one. My contact information, if you have any questions, comments, or anything that you didn't think of during this webinar, these are my contact info. So you can ask me on Twitter or whatever, LinkedIn, or on my blog, or read my blog for some additional information specific to your situation. For instance, if you don't want to give prize to some sensitive information, or for whatever reason. But like I said, there is a Q&A portion at the end of this section. So let's dig in. Why this session? Well, despite a lot of organizations are trying to tell you that mail is dead, mail is actually still very important. And but that also gives us some challenges, and we still have to maintain it, and we still have to protect our organizations from all of the harm it can do. And if you look at some news clippings, and some are Dutch, so my apologies for that. I forgot to change that to a more international view. But on the left-hand side, we have the Microsoft Digital Defense Report that comes out annually. Just recently, the 2021 edition came out, and they have an edition every year. And the general consensus, or the trend line, is that mail is still a very important vector for any breach in an organization. Just very slowly, that's the graph on the let me turn on the laser pointer. Here is a little bit of a graph of the Dutch government institutions that very gradually are improving their DKIM and SPF and DMARC policies, but DMARC policies are a bit lacking in what you would want to see. For more information, I would highly recommend to reading the Microsoft Digital Defense reports. It actually has a lot of information about what Microsoft has seen as issues, and also attack vectors or general approaches on breaches and stuff like that, but also successful mitigations and all kinds of interesting and knowledgeable things to implement in your environment. So a definite recommended read. I suppose that Microsoft is not the only one that has such a report, but this is because as I work with a lot of Microsoft products, this is just something that came across for me a little bit easier. So with this, I try to tell you that mail is still a important thing, and important to protect and to control that. So with that, I wanted to introduce a little bit of some jargon and concepts, just general, because that makes the discussion probably a little bit better, or a little bit more clear. We have with S2P mail, we have the incoming versus the outgoing mail, and that might sound quite obvious. And another terminology is ingress or versus egress. Ingress is incoming, and outgoing is the egress. But for any mitigation you might have, it is very important to be very clear about what kind of mail you're talking about. Are we talking about incoming mail, or are we talking about outgoing mail? And for specifically for anti-spoofing techniques you're going to implement, you generally are talking about outgoing mail for your organization. But for checking SPF and DKIM and DMARC and malware and stuff like that, you're mostly talking about incoming mail. So that's a very important distinction to make when discussing these topics. Well, furthermore, spam versus ham. Well, spam is obviously the unsolicited economic mail or whatever, the dirty mail, versus ham is the actual mail you want to receive from your partners and customers and colleagues. Another term is the false positive and false negative. False positives are, well, the mail is actually a malicious mail, and the detection method has deemed it as not malicious, and then it's a false positive. And the false negative is when a malicious, well, that's actually the example I just gave. Sometimes they're a little bit confusing. But a false negative is it is falsely deemed as a non-malicious mail while it is a malicious mail. So those terms are, and you see that you can easily confuse them, are quite important to get that straight. Two other topics, spoofing and phishing, are quite related. Spoofing is generally when we talk in SDP or in mail flow, it's generally the how do you say that, the masking or just making your mail headers or your presentation of that mail come from a trustworthy person while it's not from a trustworthy person. So there's an identity that is falsified in a sense. And we're going to talk a lot about spoofing in this webinar. And phishing is something that is different, but it's also often combined with spoofing. Phishing is just asking for specific information in an convoluted way, or in such a way you gain trust, or you have trust, and you just provide important information or click on a link. So that you can see that if the identity is spoofed, end users might easily click on a link or open an attachment and stuff like that. So the latter part is the phishing. The spoofing is something that is often that precedes this phishing request, basically. And as another concept is forwarding. Forwarding is the well, you receive a message and you forward it to another person. And why I mention that, it's because it kind of depends on how technically it is forwarded and which person is the actual sender in the message. And so you have basic two types of forwarding. It's the forwarding where the original sender is retained in all the headers, and a second kind of forwarding, which is what Outlook mostly uses, is the resending of a message as a sort of an attachment, and the sender is actually the second person, or the person that is doing the actual forwarding. We come back to that a little bit later on why that could be an issue in certain scenarios. Furthermore, for other concepts, we have the spam confidence level, the bulk complaint level, and the phishing confidence level. Basically, those are three values attributed to each incoming mail by your filtering solution. Spam confidence level is the most prominent one, probably, and it tries to determine whether it's a malicious or non-malicious mail, or unsolicited bulk mail, or whatever. And you can adjust those values, and the scale is from 1 to 10, and you can have a threshold like 5 or 6 or 7, and if that score is above that threshold, then your mail filtering solution will either quarantine or reject it, or whatever your mail filtering solution has been configured to do. Well, the spam confidence level is based on unsolicited mail, mostly commercial advertisements or stuff like that. Bulk complaint levels are a little bit adjacent to that, but are often from a bulk mail. You often see that with mailings and stuff like that. That value, and the phishing confidence level is dependent on your mail filtering solution if it has that level, and it's basically the amount of URLs and suspect URLs in a mail that might increase that level of the phishing confidence level. Furthermore, we have the concept of the authenticated mail, and with that, it's not the authentication as in you have a username and a password, but it's authenticated in a way. This is a genuine mail from that organization. We have the sending organization has provided enough information that the receiving organization can authenticate the mail that yes, this mail has almost certainly or certainly come from that organization that is said to be the sender in that specific mail. And that's basically what we are going to try to achieve with all those SPF, DKIM, and DMARC protocols. The last two things, signed versus encrypted, and encrypted mail versus encrypted transport. Well, I'm not a security expert, but these are some concepts we do encounter with S2P transport. Well, the signed and encrypted, signed means that a mail has been signed, so there's a signature from which you can ascertain the authenticity of that mail, either the specific sender or the sender organization. And with encrypted, the mail is actually encrypted, so any interceptor cannot read that mail. With the signed mail, someone could read the content of the mail, but the receiving party can confirm whether the sender is actually the sender or not. And with encrypted, it's basically mostly it's signed and encrypted, and you can do both. But what is different with encrypted versus encrypted transport is that you can have a specific mail that is encrypted, but you can also have the transport of the mail connection that is encrypted. The first part is often it's a end-to-end encryption as MIME or other solutions that encrypt a specific mail, and whether the transport is encrypted or not, it is safe for any an interceptor. While the encrypted transport, it's just the transport is encrypted, and mails within that transport can be encrypted, but do not necessarily have to be encrypted. So it's important to know those distinctions between signed versus encrypted and encrypted mail versus encrypted transport when you ascertain your threat level and your route of mitigation of certain challenges you might have. So those are some concepts and some general ideas that we might encounter in our further discussion of this topic. So we have to talk about the S2P or the Simple Mail Transfer Protocol because without that fundamental understanding of that protocol, it's quite difficult to understand the problems it has, and with that, which solutions you have to choose and in what way you have to implement them. So we have to go a little bit deep in the basics of SMTP, so bear with me. If you look at the documentation of SMTP, it's quite old protocol from the 1980s. It has been developed, so it's one of the first protocols ever developed for the internet. If you look at the protocols, it has been updated quite frequently, and the most latter protocols, and there are a lot of more of RFC articles that are necessary for a full understanding of the SMTP transport with all the current editions and stuff like that. But the RFC 5321 and 5322 are the most recent RFCs for the basic SMTP. And with that, we have some specific data points. We have the banner, the ELO and or HELO command, the ELO response, the mail from, and the recipient to, and the data, and then the headers in that data. That is basically, in short, the order of communication between a sending server and a receiving server. And just to make it a little bit more digestible, I made a sort of a short animation of a telnet session. So basically, SMTP is just some telnet in its most basic form, and with this I open a connection to my lab environment, and in this case you can see the label, and it's Microsoft ESMTP mail service. So this is most logically a Exchange server. So this is the banner, and then I've entered the ELO. So this is an advertisement or a sort of a hello server. I'm trying to contact you, and I've entered that as ELO and with my server name. And you see I've connected it from the MN02 server, and I connected to the EX01 server. And then with that, ELO, the SMTP receiving server, advertises the capabilities it has. It's always preceded with a 250, and then at first a hello with my IP address, so the IP address of the MN02 computer, and then all the capabilities this server can provide to the sending server. So you can see the maximum size of a message, some authentication options, and etc. And this can differ depending on how you connect and how the receiving server is configured. So with that information, I just decided to try a very simple sending a mail. And at first you have to enter the mail from, and then the sending recipient, or sorry, the sending mail address, and the receiving server has accepted that. Then the recipient, so the receiving mail address, I've entered that with RCPT2, and then the receiving server is okay. I accept this recipient. So after having done that, I said, okay, now I want to send data, and just by entering data, and then the receiving server is okay. Start with sending your data, and if you're ready, end it with the enter point, and then an enter or carriage line feed, and then it will accept that input as the end of the data. So and then I've entered some specific things, just random things, Well, I said random things, but just see that you can add things like subject or a from or other things. So you can add a lot of information in this way, and the receiving server is processing that in certain ways. So, and I've entered some random information, the end, and then did the carriage line feed to end it. And then at the end, the server is acknowledging that it has received that message and accepted that message and has queued it for delivery to the recipient. So, with this is the basic communication between a sending STP server and a receiving STP server. And this is specifically Exchange, but the basic communication is the same for any kind of STP server. And differences can come from specific versions or security settings, configuration, and et cetera, et cetera. So, and now I've entered that specific mail, it's queued and it has been received. And on the Exchange side, you can see that this was the result of that telnet connection. So, and how does that translate in message headers? Because if you receive a mail, what you see in your mail client, in this case, probably Outlook, a lot of raw data is hidden from the viewer, and it's not necessary for most of us to read at all times. But if you want to have more information about what is actually happening or what happened, you have to look at the mail headers. And I've made an excerpt of the mail headers of this specific mail, and you can see here that this is the transportation of the connection from the sending server and the receiving server. I will not go into details with this transaction, but you can see here the from information that I've entered and the return path, and in this case both are the same. But the return path is something we come back to later on. But for a quick check, I most often check whether the from and the return path are the same. So, and the recipient is obviously the administrator, like I entered, and the subject, like I've entered in that data portion of the mail. And then some extra headers that are added by Exchange or your STP mail filtering solution. And for all important things, you can have the message ID, which can be used to trace a specific mail transportation or events or what happened or in your logs. And you can also have some X headers, which are custom headers that could provide some extra information that might be relevant. But for now, the basic parts are the transportation headers, and then the recipient and sender information, and the subject and stuff like that. Just to give a general sense of a simple STP communication between a sending and a receiving server, and then how that results in the specific mail and how that ultimately translate in the message headers. So you might have seen that there could be some problems with SMTP. I've already really alluded to it a little bit, but basically the session about this is in a great part. We'll talk about spoofing of mail. And what is the most important thing that is troubling with STP delivery? Well, one thing, it has been developed in the 1980s when the internet was a whole different concept or usage was completely different than it is now, and security by design wasn't a thinking at that time. So we have some issues with SDP, and this is another example of a mail transportation, and now in this case it's an example of spoofing. So spoofing of the sender address. So if we look at the left-hand side, this is the telnet session, just like the previous example, and on the right side are the message headers. And I would like to point out the similarities in the telnet session and in the message header. So because with that information you can perhaps a little bit easier read into the mail headers and understand what it says, the message, and how it correlates to the specific communication. So on the left-hand side we have the banner and the receiving server, and we have the sending server, in this case the DC10, and it's also highlighted in the mail headers. Well, we have the mail from, and in this case I've entered the bounds at bounds.contoso.com, and you can see that back in the return path value in the message headers. And it's a very important distinction to make. So because well, at first we have here the recipient, and the recipient is basically the to address. And then we have the data, and more importantly, within the data, we have the from the @spoof.com address. And that coincides with the from header in the right side in the message headers. And this is actually the header, or sort of the sender information that is presented by Outlook, or basically every mail client, as the display name or the information that is provided to the end user. And you can see that this has been accepted. This all information has been accepted by the receiving server without any discussion or any hesitation. But this is quite a problem, because and we have to look at the definition within the RFCs. You can forget those numbers right away, but the from this header is different from the return path. The return path is something the end user basically doesn't use. The end user client always uses the from. And as you can see, I can enter anything what I want in this scenario. So I can spoof anyone. And if, just to make an example, this domain hasn't been added to that receiving server or anything, or wasn't checked by the receiving server. And just to look at what the end user is seeing, well, this is the webmail version, but the receiving server just sees the spoof.com mail address and not the Contoso address. So that is a problem, and this is basically this is the main concept of spoofing your mail. There are some other variants of that, but this is the basic portion. Well, how do we solve those? And like I said, SMTP was generally designed in the 80s and has been tweaked along the way, and that has had a lot of additions. And one of the most earliest addition is the sender policy framework, and I hope that most of you are familiar with that. And it's basically an indicator that signals which senders, which servers or IP addresses are allowed to send mail for that specific domain. And the receiving server can determine the domain you're talking about from the mail from or the ELO response. So that's the return path a value in the message headers, and it controls that IP address, or it checks that IP address in a list of a DNS record, which is a text record, and has a list of IP addresses that are allowed to send. An example is for instance, for mailserver.nl, just an example value, and that DNS text value is V is SPF1. It's an indicator of which protocol it uses. And then in different ways, you can add DNS A records or IP addresses, or you could include a different SPF text record that contains a lot of other information and or other values, and a minus all, and that determines that no other server is allowed to send mail for that domain. It's a very basic example, this, but one of the or some of the disadvantages of SPF is that you need a complete understanding of your egress mail. So you have to know each IP address or the domain name that is allowed to send for your mail domain. And also another issue is that there is a maximum of 10 cumulative DNS lookups. So the MX, A, or include tags, if they have a record, for instance, that counts as one DNS lookup. And if you have more than 10, then your DNS or your SPF record will result in a permanent error, and no in the specification, it's designed that receiving servers don't have to adhere anything of that SPF record. So basically, if you have more than 10 DNS lookups in your SPF record, then receiving servers consider that as a permanent error, and that constitutes basically the same as having no SPF record. Well, that could be a problem if you have missed or if you do not check for those DNS lookups. Another issue is the forwarding. The example that I gave at the beginning of the session was that if you have a forwarding concept that retains the original sender and basically the return path of the sender, it would fail the SPF check, because the intermediary server is probably not a member or a server that is mentioned in the SPF record. So a receiving server should fail that, and forwarding would break. There are some solutions for that issue, namely the sender rewriting scheme, and Microsoft 365 has that implemented. And what that does is, before sending or forwarding that message, the return path mail address is changed to an address that will not fail the SPF record, and it will use a domain that is valid for the intermediary server, and that domain will have to be and that IP address of the intermediary server is entered in the domain of that SPF record of the intermediary server. So it's a bit of a sort of a tag, and the intermediary server just replaces that value. If you're worried about replying should be retained and should go to the original sender, even if it's forwarded. Another disadvantage of SPF is that subdomains, if you have any subdomains, they require their own SPF record. So if you have a lot of subdomains, you have to have a lot of SPF records for each subdomain. So that's unfortunate, but yeah. So that was a little bit of SPF. For another thing, So SPF prevents or allows specific IP addresses to send mail, but like the disadvantages say, it's not perfect. And especially in the era of more cloud-based solutions and sending your mail via cloud solution, it could be that a lot of organizations use the same SPF records, and so the value of SPF has been a little bit, well, it's not perfect. It's still not a guarantee that that specific mail has originated from a specific organization, and that is what domain keys identified mail, or DKIM, trying to resolve. And it does that by signing every mail that exits the organization or the sending organization, and it signs every mail with a specific signature, and it's based on a private and public key concept. The sending organization has the private key, and the public key is published in a DNS record that the receiving server can read, and in combination with a hash portion within the mail that has been sent, and that hash has been calculated by the sending organization with that private key, and then the receiving organization, in combination with the public key, can check whether the signature has been altered or is valid. And it can, in this way, check the authenticity, but also whether some information has been changed in that mail. So this is a vast improvement on being sure that that mail is from that sending organization. And like I said, it's entered as a DNS record, always a text record format. And you can have multiple DKIM keys corresponding with your private key, and you can also have a CNAME redirection, which point to a text record, and that's an important feature for if you have different services or multiple private keys in different mail services. And you can point that with the CNAME record to enable the receiving servers to find the correct public key. So disadvantages: well, you have to have a sending server that is able to sign that. Not every application or software as a service supports DKIM. For instance, on-prem Exchange doesn't have any DKIM support without any plugins or filtering solutions that are in front of that. And another downside is that valid manipulation, like disclaimers, could break that. If a message has been signed and certain portions of that message are manipulated, like for instance disclaimers, which are valid, but those could break the DKIM signing. So you have to take that into account when implementing certain manipulations, and take into account at what point DKIM signing takes place. So those are SPF and DKIM. And then lastly, we have DMARC, the domain-based message authentication, reporting, and conformance. That's a mouthful. I always have to check what that acronym stands for with the cheat sheet. So like I said at the beginning, the spoofing, you can enter any information in the mail from, and then in the data portion, you can enter any mail address in the from header. And that results in spoofing a sender information. So the actual sender could be somebody totally different, and then in the from information, it could be your own CEO, for instance, and that's quite a common way of phishing mails to entice financial controllers to make a unwitting donation to a malicious organization. So, and DMARC checks whether both of those values are correct. So the from header after the data portion, if that mail address is actually the mail address that is also the sending organization. And it also checks the results of the SPF and DKIM checks if that is configured of the sending information. So it's if you are willing to implement DMARC, you also will have a great benefit if you also implement SPF and DKIM. But basically, those three protocols go hand in hand. But what the most interesting thing is that DMARC can suggest specific actions like reject or none or quarantine to the receiving organization in case any of those checks fail. Another big improvement compared to SPF, for instance, is that the sending organization can receive reports of misuse of your domain, the DMARC reports, and you can, and that doesn't have to be any actions that your sending organization has performed, but it can also be a malicious sender that is trying to misuse your domain and trying to send mails from your domain in a malicious way, and then the receiving server, if that receiving server is checking for that, can in that case signify or signal you, well, this has happened from that and that IP address. So well, this is an example of when there is misuse, but it can also, if you have a misconfiguration, you can also receive reports of specific IP addresses that have tried to mail and your DMARC information didn't align with all the SPF and DKIM information. So for shadow IT, if a department has purchased a software solution that doesn't adhere to DMARC and stuff like that, you can get a report and find that information and then try to mitigate that. So it's in one part a sort of a troubleshooting reporting, but also a report of attempted misuse, and which you can hunt down even further if you wish to do so. Another improvement is that subdomains automatically follow the main policy. So unlike SPF, all subdomains automatically follow the policy defined at your highest level. But if for any reason, if you want to have a different policy, more strict or less strict, you can do that. So you can have the main policy. You can have, for instance, that if a DMARC fails, you can have quarantine, and then in the subdomain you can say, okay, if the DMARC fails, then you have to reject it, for instance. So those things are possible and will make the maintenance of DMARC a little bit more easier and more flexible than compared to SPF. Although they do different things, but they have learned from the implementation of SPF what kind of the things that we were missing, and then have implemented in DMARC. So, and in DMARC, it's also, again, a ticks record, and it's basically somewhat comparable with SPF. We also have the V is DMARC 1, it's the version and the protocol. The P stands for the policy that has been defined. In this case, it's a reject. You can also have a quarantine, or if you are are in the early stages of deploying DMARC, you can do a P is none. And then that means that you will have a DMARC policy in place, but it's not, the receiving servers do not have to do anything, but they know you are busy with a DMARC. And you can also already have some mail addresses in place to which those reports are sent towards. So you can have, in your initial stages of deploying DMARC, you can have a P is none. No policy is implemented at the receiving ends of servers that support DMARC, but if a DMARC failure has been detected, you will get a report. And so you can mitigate any misconfiguration you have in your organization with this kind of information. Unfortunately, not all organizations send DMARC reports. Most notably, Microsoft 365 isn't sending DMARC reports at the moment. So that's a bit of a downer, but organizations like Google, Yahoo, and some internet providers do send DMARC reports, so you can get a little bit of information from those organizations. And because you can have subdomain differences, every subdomain is checked first whether a DNS record exists. If it doesn't exist, then it will go to a organizational domain. So if you have services.contoso.com, it will check services.contoso.com if a mail sender address contains that domain. And if no record has been found in DMARC, then it falls back to contoso.com and checks whether there is a DMARC record in that organizational domain. That is a bit explained here in more graphic examples. At the end, if there is no DNS record, then the DMARC check will be skipped. So the receiving server will not check any further. It could check for SPF and DKIM, but a DMARC check will not be performed. And that can have some resulting effects in whether your mail, that sended mail has been accepted as malicious or suspect or whatever. But that is dependent on the receiving server. So like I said, disadvantage of DMARC, and one of the most biggest disadvantages at the moment is that not every receiving server checks DMARC, which is unfortunate. Because although you have implemented your DMARC policy, if the receiving server doesn't check that, then they are still prone to spoofing attacks, for instance. And like I said, not every receiving server sends reports. Another thing is that valid forwarding is broken in some cases. So I previously said with the SPF record, you have a solution like SRS, that's a sending rewriting scheme. Unfortunately, that only solves problems with SPF and doesn't resolve the DMARC checks in such a way that the from address and return path address are still not aligned, as it were, or are not the same, and then that would fail the DMARC. There are some other solutions for that, but I'll come to that in another sheet. And also, you have to analyze those reports that come in, and that could be troublesome because it's basically XML files. So it could be prudent to use a reporting service. There are DMARC.com, DMARC.org has a list of services that are provided, but often they ask a fee for those analysis and stuff like that. So that could be a downside for your implementation of DMARC, especially if there are high costs involved, if you have a lot of domains. Especially at the beginning, you will make very use of it in your beginning of your implementation, but after a while, it probably stabilizes and you don't have to rely on the reports that often, probably. So that could be a reason that your return on investment is maybe not what you would like to see. So common challenges in general with the SPF, DKIM, and DMARC implementation. Like I said, legitimate forwarding. It's in every case, it's a problem. Mailing lists, for instance, or if you have a forwarding rule, those kind of things, if they are valid, they could break. There are some solutions with that, but it's another band-aid on the whole system that has to be supported by the receiving end as well. So maybe it's not always that perfect. The SPF record limits is also something that I've encountered numerous times, that the SPF record has some issues with it. Mostly the DNS lookup value has been exceeded and then has a permanent error. Also, a lot of organizations have subdomains and struggle with that, how they have to use that, or forget to implement DKIM, DMARC, or SPF correctly for a subdomain, but have done that for the organizational domain or the main domain. Well, a lot of organizations, especially now with cloud services, use services that you want to require that they send mail from your mail domain. For instance, for your payslip, for instance, or HR has some products, or your whatever that is, and you want to have that mail sent from a trusted domain, but that means that that organization, if you have SPF, DKIM, DMARC in place, that those kinds of organizations also have to have at least DKIM in place as well. And if they don't, well, that could break your strict policies, for instance. So if you have very strict policies, and if certain mails are not allowed to be, or are suggested that you have to, that the receiving end has to quarantine mail, but you make use of a mailing service that doesn't support DKIM, for instance, then that mail could end up in the junk folder or the quarantine folder of that receiving organization. For instance, if you're using MailChimp, for instance, and you don't configure DKIM, or another service that doesn't have any DKIM support. So, and that would limit your organization for your own implementation, for strict implementation of certain protocols. So that has to be taken into account in your designing your whole SPF, DKIM, DMARC stance. And in a lot of cases, if you cannot select a service that supports DKIM, what you could do is use a subdomain for that specific service, and for SPF, DKIM, and DMARC, make less strict policies for that specific subdomain. So in order that your organizational domain can be very strict with all those DKIM and DMARC policies, but your subdomain are a little bit more loose because your intermediary or your services isn't able to do, for instance, DKIM. I see that a lot, and subdomains are a solution for those kinds of issues without compromising your own security for the organizational domain or your main domain. But still, it doesn't prevent mail from compromised accounts. So SPF, DKIM, DMARC do not protect against that. It actually assumes that your organization is trustworthy, or it basically says this mail has come from this organization and we vouch for that. So the organization that is sending that has to prevent being compromised. Well, everybody should prevent to be compromised, but take this into account that even though a mail has checked all the boxes for SPF, DKIM, and DMARC, it still can be a mail from a compromised account or even a whole environment. So do not take the DKIM, SPF, and DMARC checks of approval as saying, okay, this is a non-malicious mail. It could still be a malicious mail. And another thing is that malicious Unicode domains. So you could have a mail domain that looks like it's from Microsoft.com, but one of the the most easiest one is replace the O from micro or soft with a 0. And computers make a distinction, and computers can have you can have a valid SPF, DKIM, and DMARC record for that domain, but the human will probably read it as Microsoft and not micro or mic 0s0eft.com. This is a very simple example with the 0 and the O, but with Unicode you can have a lot of different kinds of characters that look very, very, very similar or almost exactly the same, but are computational quite different characters. So that is another reason that if SPF, DKIM, DMARC checks are passed, that the mail could still be malicious if they use this kind of trick. Your mail filtering solution should check for those kinds of things, and anti-phishing protocols could check for those kinds of things. If for instance, that if it's your own mail domain that looks like, for instance, the contoso.com, and you receive a mail from Contos, but then with zeros, you might not see that it's an external mail actually. So be wary of that. And lastly, but basically one of the biggest challenges I've seen with mail spoofing solutions is that organizations don't have a process in place to support and maintain that mail flow. I've seen a lot of issues with correct SPF records being made, or when a service has been acquired, that there is no check whether it supports DKIM or stuff like that. And having a process in place that continually checks those things, that everything is aligned, is very, very much important, and is one of the biggest things that I see go wrong in organization. So check if your organization have a correct process in place, and provides changes like an additional software as a service acquisition and an additional domain that has been purchased and stuff like that, that also have to come into place in your mail flow process. So is this it? Well, well, we're a little bit over time, but I can talk hours on this subject, but unfortunately we don't have that time. But I will mention a few other protocols that help with all kinds of other different stuff, like the SMTP TLS for the encrypted transport, but also with the validation of these sending and receiving server. Well, I already talked about the sender rewriting scheme for the forwarding issues with SPF, but for DMARC, that also has an issue with the forwarding issue. We have ARC, and I unfortunately have forgotten the acronym for that. Oh, it stands there. Authenticated received chain, and also fixes the forwarding issues from DMARC and DKIM. So just know about those protocols, that they can help additionally with your controlling your enterprise mail flow. Checking mail headers, I already had done some checking with the example, but I probably don't have time for that. But useful tools, Telnet. It's an easy, usable tool, and like I presented it in the beginning, you can use that to check certain basic stuff of your organization. And the message header analyzer tool, it's a site from Microsoft, but also an Outlook add-in. And unfortunately, this hasn't been aligned very well. But you can add that in your message client, and then you can see the most important stuff a little bit more easier. MX Toolbox also has a similar tool, and for checking your domains, I've written a little bit of a PowerShell script that checks the MX SPF DMARC records and in some way the DKIM, the existence of DKIM records as well. So that's one easy tool that I always use when I come into an organization about and have to talk about the Mailflow thing. So unfortunately, I don't have time, I think, for the demo, but it's basically just a demo to highlight the message header analyzer site. You can find that from exrca.com from Microsoft, and that will redirect you to the testconnectivity.com site. And then you have that the message header analyzer. And the Outlook add-in can be found in the Office store. And with that, I've come to the end of my talk, a little bit over time. I hope you found this useful and have found some interesting things. I'm happy to answer any questions. Maybe you already had some questions added in the chat. But if you don't want to wait for the chat to have another meeting, you can contact me in other ways, like here. And with that, I would like to thank you for your attention, and I hope to talk to you soon.
Great. Thanks very much for that, Dave. Thanks very much for that session. I'm afraid we are a bit over, so if someone has a question, hopefully they can take down your contact details there, and we'll send the webinar recording to everyone so they'll have a screenshot of your details so they can contact you. Yep. So thank you very much. That was great, well explained. I'm afraid we have to wrap it up now, but thank you for your time.
You're welcome. Bye-bye.
Thank you. Have a good day. Bye.